Now, each winter, the Idaho Department of Fish and Game conducts big game counts to determine how well our wildlife populations have fared over the last year. And if the mule deer numbers south of Twin Falls are any indication, 1995 is looking good.
On this Sugarloaf and Dry Creek winter ranges, deer numbers are up about 30% over last year, which is quite encouraging because the severe winter of 92-93 generally reduced these deer populations by about 30% in this area. So the numbers that we've seen on this flight the last couple of days suggest to us that populations have rebounded and recovered quite well.
It certainly looks like it from here. A vast herd of mule deer races across the plateau slightly ahead of our helicopter, which brings up the obvious question. How do biologists actually count individual animals when confronted with groups this large?
I got 88. I got 83.
And typically there's 2 observers plus the pilot on board, so all 3 people can be counting and you can compare notes and see just how close you are. And typically you can come within 3 or 4 animals. If you're into a group of 200, typically all 3 observers will count pretty close.
Of course, some experience helps and a tendency not to get airsick, but the technique is quite simple. The biologists actually enumerate each animal they see. Now try testing yourself. How many deer do you see in this picture? We'll even make it a bit easier and freeze the shot. Here's what wildlife biologist Randy Smith and pilot Brent Wood came up with.
59. I got 58. That's very close.
How did you do? Randy says it's generally easier to count deer against a white backdrop, but despite the lack of snow cover, this year's early spring weather has actually worked to their advantage because it tends to concentrate the animals along a narrow strip of green-up.
Okay, looking for another group? Yeah.
If a herd is too large to count in a pass, the helicopter pilot simply splinters off a portion by maneuvering between them.
Quite a few there. That might be one group we need to split some off, count everything on the right.
The one nice thing about mule deer is you don't often count them in trees like you might with elk and other things. Our winter ranges here are primarily fairly open country, and they're not that difficult to count.
But what about those other situations? How do you count elk concealed in the thick stands of pine winding along the Locksaw River, or bighorn sheep hidden among the rocks in the canyons of the Owyhee Desert Country? How do scientists estimate population numbers where actual animals are difficult to see? In recent years, a significant tool has been created in wildlife biology to address this problem. It's called a sightability model. A few years ago on Incredible Idaho, we brought you a story on how such a tool was developed to estimate the number of California bighorns that live in the Owyhee Desert. The dun-colored coats of the wild sheep easily blend with the muted hues of the desert environment they inhabit, making it difficult to spot them from the air. Once again, you're the wildlife biologist. How many sheep do you see in this picture? Now, even as we close in, until they move, the bighorns are almost impossible to detect. The idea behind the sightability model is to compensate for sheep the observers cannot see from the helicopter. Of course, that can depend on the type of terrain, the density of the vegetation, and the activity of the animals. All these factors must be accounted for when developing the sightability model.
We put observers out on these various points out here, and then they have sheep in sight. We come flying through in a helicopter like we were doing a standard census, and we have the observers on the ground tell us whether or not we saw the sheep.
One of the ground observers is research biologist John Doremus from the Bureau of Land Management.
The idea is for me to watch the sheep so that when the helicopter comes by, we'll have an idea of how many they see or don't see of the ones that I am watching.
After 5 years of this kind of data collection, a computer model has been developed on the Owyhee bighorns by the Idaho Department of Fish and Game in cooperation with the Bureau of Land Management and the University of Idaho. they found that in canyon country like this, the helicopter crew detects 67% of the moving sheep. Of the bighorns that are standing still, only 33% are seen from the sky. But up on the flats, visibility increases dramatically. Here, 70% of stationary animals and 91% of the moving sheep are seen by the helicopter crew.
Okay, I've got 2 rams down here in the Rim Rock, group number 34.
Overall, according to this study, the aerial surveys spot 66% of the sheep that are within sight of the ground observers. Equipped with this kind of information, wildlife biologists can plug the actual numbers from the aerial surveys into this computer model and come up with a more accurate population census on the Owyhee bighorns. This results in better management decisions that ultimately affect Idaho sportsmen. A similar sort of computer model has already been developed for aerial surveys on Idaho's elk population. And by this time next year, Randy Smith will be using a new siteability model developed specifically for mule deer.
In the past, we would fly, and the one big question that remained at the end of the survey was what percentage of the deer population did we actually count? And we never had a good way of knowing how many deer we missed and how many deer we counted.
Now, when the biologists fly mule deer surveys along with animal numbers, they also record several other factors such as the vegetation type, the percentage of the area that's covered with vegetation or snow, and the activity of the deer.
And we found that if we record those variables for each group of deer that we see, that a computer model will help correct for the actual numbers of deer out there. So for the first time, we're actually estimating deer populations with a known level of precision.
Reliable information like this is the key to good management for our state's wildlife resource.